Now we have seen the problems regarding the estimation. But when the sample size is given and they are asking you to find the probability between the random variables, means between the sample mean here, then we have to use the standard normal variate. Now let us see the first problem on this. The mean height of students in a college is 155 centimeters and a standard deviation of 15 centimeters. What is the probability that the mean height of 36 students is less than 157 centimeters? Now to solve these problems here, we have to use the standard normal variate, which is z equal to x minus mu by sigma. But here, when the sample size is given, then we have to use z equal to x bar minus mu by sigma by square root of n. So mu and sigma, mu is the mean of the population, sigma is the standard deviation of the population. But when we are considering a sample from the population here, then in place of x, we have to take x bar. And since we are considering the sample size, so sigma by square root of n. So why it is sigma by square root of n means here, they are asking you to find the probability that mean height of students is. Means for the sample mean we have to find here. And we know that the standard error for sample mean is sigma by root n here. So that's why here it is sigma by root n. Now if you move on to the given data here, the mean height of students in a college is 155 centimeters. That means mu equal to 155 and the standard deviation of 15 centimeters, sigma equal to 15. So what is the probability that mean height of 36 students, right? So sample size is 36 is less than 157 centimeters. That means probability of x bar less than 157 we have to find here. So that means here x bar is 157. Now how to identify the mu and x bar here? So sometimes you may get confused with the mu and x bar values. So followed by the sample size, if they mention the mean of, that means that is the sample mean. And directly they have given the mean and standard deviation, means that represents the population mean and population standard deviation. Okay. Now here we have to use z equal to x bar minus mu by sigma by root n here. Now let us simplify this. Z equal to x bar means here 157 minus mu means 155. Sigma means 15 by square root of n is here 36. Okay. Now that is 157 minus 155 is 2 divided by 15 by square root of 36 means it is 6. Now what is this here if you simplify? 2 by 15 by 6. So it is 0.8 here. So z equal to 0.8, which is greater than 0 here. So if you consider the curve, normal curve, so we know that the normal curve is a bell-shaped curve here. Okay. So z equal to 0.8 and here we are finding probability of x bar less than 157. That means we are considering the left panel here. So here the probability, the z value is getting as greater than 0. So by solving the normal distribution problems here, we have learned the formulas here. So to find probability of x less than something, if z is less than 0, it is 0.5 minus a of z1, area value of z1. And here, if we are finding probability of x less than something and the z value is greater than 0, then it is 0.5 plus a of z1 here. So here also we are finding less than and here z value is getting as positive here. So this probability of x bar less than 157 is given by the formula 0.5 plus area value of z here. So what is the area value of 0.8? It is given as 0.2881. So 0.5 plus 0.2881 here. So it is nothing but 0.7881. That means probability of x bar less than 157 is 0.7881. So for this left tail here we are finding, and this is z is 0.8. 0.8 means this part here. Okay, so you can draw the normal curve or else simply you can write like this also. Okay, but you get the marks if you represent the normal curve very effectively. So here the probability that the mean height of 36 students is less than 157 centimeters is 0.7881. Now let us see second problem. The mean of certain population is equal to standard error of the mean of the samples of size 64 from that distribution. Find the probability that the mean of the sample size 36 will be negative, and the table value of 0.75 is given as 0.2734 here. Now this question is quite different. Now the mean of certain population is equal to standard error of mean. So what is the mean of the normal population here? Mu. So that mu is equal to standard error of mean of the sample size 64. So that means here mu equal to sigma by root n it is given. Mean of the certain population is equal to standard error of mean of the sample of 64. So that means here when n equal to 64, then mu is here sigma by square root of 64, that is sigma by 8. Now what we have to find? Find the probability that the mean of the sample size 36 will be negative. So mean of the sample size 36 will be negative means here probability of x bar less than 0 we have to find when n equal to 36. So we know that z equal to x bar minus mu by sigma by root n here. So this becomes here x bar minus mu means sigma by 8 and sigma by root over 36, because we have to find probability of x bar less than 0 when the sample size is 36, right? So if we simplify this here, so z equal to, this is x bar minus sigma by 8 by sigma by 6. Square root of 36 is 6. Now simplify this, this is 6x bar by sigma minus, right? So 6 into sigma by 8 by sigma. 6 into sigma by 8 into sigma. So this sigma will get cancelled. Then z is here 6x bar by sigma minus 6 by 8. If we simplify 3 by 4, which is nothing but here, or we can write 3 by 4 0.75. That is your z value here. Now we have to find probability of x bar less than 0 here. So probability of x bar less than 0 means the sample size 36 will be negative, means if you consider the normal curve here, right? So negative means here they are asking the left eye. So but 0.75 means this part. This means this total value we have to find here. So it is less than 0, but here we are getting the z value as 0.75, which is positive. But before you may get it out, that before we have a minus sign, that is z equal to, but not this value. If you are getting here minus 3 by 4, then ultimately it will be negative here. But here it is only plus 3 by 4. So this is positive, and here we are finding for left tail here. So that means the formula will be 0.5 plus area value of 75. That is 0.5 plus the area value is given as 0.2734. So that means 0.7734 here. Okay. So the probability that the mean of the sample size 36 will be negative is 0.7734. Now see the third problem here. A normal population has a mean of 0.1 and standard deviation of 2.1. Find the probability that mean of a sample of size 900 will be negative. So the table value of 1.43 is given as 0.4236 here. Now if you write down the data here, the mean is given as 0.1 and the standard deviation is given as here 2.1. So find the probability that mean of a sample of size 900 will be negative, means n equal to 900. So again here also we have to find the probability of x bar less than 0 we have to find. So z equal to x bar minus mu by sigma by root n. So x bar means here we don't know, right? So x bar minus mu value is 0.1 by sigma 2.1 by square root of 900. So z equal to x bar minus 0.1 by 2.1 square root of 900 is 30. So 2.1 by 30 is here 0.07. Now z equal to x bar minus 0.1 by 0.07 is there. So from this here x bar can be written as, right, 0.07 into z plus 0.1. Okay, x bar can be written as 0.07 into z plus 0.1, because here we have to find the probability that mean of the sample will be negative. That means probability of x bar less than 0. What is x bar here? 0.07 into z plus 0.1 is less than 0. Right? Now, this can be written as 0.07 into z is less than minus 0.1. So, if you bring this side, this becomes minus 0.1. Now, from this, probability of z is less than minus 0.1 by 0.07. So, what is 0.1 by 0.07? It is 1.43. Okay. So, probability of z less than minus 1.43. What we are finding? Probability of x bar less than 0, and here also it is negative. So, if you draw the normal curve here, we are finding this part left side, and this is also negative, minus 1.43. Now the ordinate for 1.43 is 0.4236. So we are finding x bar less than 0, here also less than, and here also it is less than 0. So probability of x bar less than 0 is given by the formula 0.5 minus area value of 1.43. So that means 0.5 minus 0.4236. So this is here 0.0764. So that means probability of x bar less than 0 is 0.0764 here. Okay. So when nothing is mentioned about the sample mean condition, then directly here using this z formula we can simplify the x bar, right? And that we can substitute in the whatever we have to find, that is probability of x bar whether less than 0 or greater than 0. Okay, is it clear? I hope you understand this problem. Now let us see the problem where we have to find the sample size when the mean and standard deviation sample mean are given to us. If the mean breaking strength of copper wire is 575 lbs with a standard deviation of 8.3 lbs, lbs means the physical units, how large a sample must be used in order that there will be one chance in 100 that the mean breaking strength of the sample mean is less than 572 lbs here. So there will be one chance in 100 means that is the probability of the sample mean they have given here. So if you write the given data, the mean breaking strength of copper wire is 575. That means mu equal to 575 with a standard deviation of 8.3. Right? The sample size we have to estimate how large the sample must be used. That there will be one chance in 100 that the mean breaking strength of the sample mean is less than 572. That means x bar is 572 and probability of x bar less than 572 is given as one chance in 100, means 1 by 100, which is equal to 0.01 here. Now this time we have to estimate the sample size. So z equal to, we know that z equal to x bar minus mu by sigma by root n here. So what is x bar? 572 minus mu value is 575 by sigma value is here 8.3 by root n. So this is z equal to. Now if we simplify this, z equal to, so 572 minus 575 means here minus 3 by 8.3 by root n is there. So that root n minus 3 by 8.3 by root n becomes minus 3 by 8.3 into root n here. But here it is given that the sample probability of the sample mean is less than the, means the probability is given as 0.01. So that means if you draw the normal curve here, it is 0.01 means this part here. Now the probability is given, then what about this part? Because we know that the probability of the left child is 0.5. So here it is given as here A of Z is equal to 0.01. So 0.5 minus 0.01 is 0.49 here. So that is A of Z. But using this value, we have to find the ordinate, means we have to find the Z value here. So from the tables, if you identify here, the ordinate means the area value of 2.33 is 0.49. That means the ordinate will be 2.33. So that means Z equal to 2.33 here. But it is 0.01 means it corresponds to left side. So we have minus 2.33. Now substitute this in this one. So minus 2.33 equal to minus 3 root n by 8.3. Minus minus will get cancelled. So here 3 root n is 2.33 into 8.3, which is equal to 19.33. Now from this root n is 19.33 by 3 here. So it is 6.4. So this is root n, but we want the sample size n. So n equal to 6.4 square. Make a square of this. It is 41.5. That means the sample size is approximately 41 here. Okay. So clearly it is given in the question that how large a sample must be used in order that there will be one chance in 100. So that is the probability, right? That the mean breaking strength of the sample is less than 572. So here they are asking less than, right? And here also we got minus. Okay, so less than means automatically it will lies in the left hand here. So that's why your Z value will be minus 2.33. So in this way you have to estimate the sample size when the sample mean is given. Now let us see the last problem in this unit. A random sample of size 64 is taken from an infinite population having the mean 45 and standard deviation 8. What is the probability that x bar, means the sample mean, will be between 46 and 47.5? So first we write down the given data here. So a random sample of size 64 means n equal to 64 is taken from an infinite population. Infinite means we can consider it as normal only, because normal distribution only lies from minus to plus infinity here. Having the mean 45, that is mu equal to 45 and standard deviation is 8. What is the probability that x bar will be between 46 and 47.5? That means probability of 46 less than x bar less than 47.5 we have to find here. So that means here x1 bar is 46 and x2 bar is 47.5. Now let us consider z1 as x1 bar minus mu by sigma by root n and z2 as x2 bar minus mu by sigma by root n here. So x1 bar means 46 minus mu means here 45 by sigma is 8 by square root of 64. So 46 minus 45 is 1. Square root of 64 is 8. 8 by 8, it is totally equal to 1 here, which is greater than 0. So this is Z1. Okay. Now if you move on to Z2 here, x2 bar means 47.5 minus mu value is 45 by sigma value is 8 by again square root of 64. So 47.5 minus 45 is equal to 2.5. So 2.5 by 1 is equal to 2.5, which is also greater than 0. Now if you consider both the left tail and the right tail are greater than 0 here. And we are finding probability of 46 less than x bar less than 47.5. When this is the case, we have a formula that probability of 46 less than x bar less than 47.5 is equal to, when both are of same sign, we have the formula modulus of A of Z2 minus A of Z1. So modulus of A of Z2 means area value of 2.5 minus area value of 1. So it is given in the question area value of 2.5 is 0.4938 minus area value of 1 is 0.3412. Okay, so this is 0.4938 minus 0.3413 is 0.1525 here. So that means the probability that 46 less than x bar less than 47.5 is equal to 0.1525. Okay, so in this way we can estimate the probability of two sample means from the same population. So with this we have completed the third unit. I hope you understood this problem.